Welcome and hello. This is a video exercise in HEC ResSim. And in this exercise, I'm going to talk about scripted rules. Scripted rules are a way for you to define the release rule from a reservoir by writing a script in Python, which is like Python for Java. Okay, so what I have on the screen here is a brand new instance of HEC ResSim version 3.3. We're going to go through the steps from the very beginning to demonstrate a few of the scripted release rules. All right, so let's go ahead and get started. We're going to go File, New Watershed. Keep note that I'm in the Watershed Setup module here, and then I'm going to give my watershed a name. I'll call it Exercise 18. You can call your watershed whatever you want, and then select the directory that you want that watershed directory to be created in, and then select the time zone, units, and then click OK a few times. And the watershed's been created. All right, if you've seen me do this before, you can probably skip ahead because I'm going to sketch out the same watershed with a single reservoir. But if you haven't, then this is what's happening. I'm going to click my stream alignment tool here over on the left, hold down Control, and then do a couple, hold down, single left click a few times just to sketch out an alignment, and then let go of Control before your last click, and then give the stream a name. Click the computation point tool, hold down Control, and then give that a name. I'm going to select the reservoir tool, hold down Control on the upstream end, click, let go of Control, and then click again on the downstream end, which would be like the dam face end of the reservoir. Call that Reservoir 1. All right. Whenever you're sketching reaches, stream alignments, reservoirs, you want to first click on the upstream end and then on the downstream end after that. Okay, we'll add one computation point at the bottom or towards the bottom of the stream alignment. And that's good. Let's go ahead and create a configuration. I'm going to go configuration new. I'll just call it config 1. We're only going to have one configuration in this exercise, so the naming doesn't have to be particularly specific. I'll click apply. I'll click OK. And then I'm going to go File, Save Watershed. Okay, so that's all we need to do in the watershed setup module. I'm going to next go to the reservoir network module. There's more work to do here, so let's get started. Network, new. This is the first step, and we're going to select config 1. That's the configuration that we just saved over in the watershed setup module. I'll name it network 1, and then new. That brought in our reservoir. I need to connect the junctions, so I'm going to click the reach tool here in the left tool menu, hold down Control on the upstream junction. Oops, click. There we go. And then let go of Control, and then click again. And the name, I can just reach, and then click OK. Do the same thing for the downstream reach, and OK. I'm going to go ahead and save the network. Next, I want to identify inflow at the upstream junction. So I'm going to right click, edit junction properties. And then I'm going to click the local inflow tab, call it inflow at CP1. And then OK. Apply. OK. Let's go ahead and define the time series dataset now that would define that inflow. I'm using English units as I set up the watershed, so that flow would be in CFS. And to do so, we'll go ahead and click Tool, HEC DSS View. And then this is, we'll go File New, just to create a new DSS file. I'll call it Time Series Data. Okay, the file's been created. Here's the tab to represent the file here. I don't have any paths yet in the DSS file, or you can call them records or data sets, but we're going to make one right now. So go data entry and then manual time series, where you can import from Excel. That's also an option. I'm just going to go manual and then paste in my values from Excel. So I'm just going to be generic and call it project, location, flow, and then I'm going to call this 2000, 5000 CFS. And so the start date would be 01 May 2024, the first hour of the month, unit to CFS, and then the type of instantaneous value is fine. Okay, I'm going to go ahead and paste in some values. Okay, I went over to Excel and copied my values onto the clipboard. So now I'm just going to Control V. There they are. So it starts at 2000 CFS and then it ramps up to 5000 and back down a few times. I'll show you what that looks like in a plot just to make it easier. But for now, I'll click Save. And then, okay, I don't need to return to the data screen. So I'll select the record. It's been created right here. And then select the plot. And as you can see, it starts at 2000 CFS and then it goes up to 5000, back to 2000, and so on. I'll close that for now. We will assign that a little bit later when we create an alternative. Okay, next I'm going to select the reservoir tool. Right click on reservoir, edit reservoir properties. And then here is my reservoir editor dialog box. I'm going to select the first field here and then Control V and paste. So I was just over at Excel. I have this data pasted on, copied onto my clipboard. And you can pause the video if you want to use these numbers. But basically the base elevation is 1350 and the top of the dam elevation is 1500. So I'm going to type in that 1500 here and I'll just make up some length at top of dam. And we're going to add a controlled outlet here. And again, I'm going to paste in data that I just copied over onto my clipboard from Excel. And it's going to have an invert of 1350. And as you can see, as the elevation of the water surface in the reservoir pool increases, so that the max capacity through a single gate. I'm going to come up here and say there's actually 5 gates. So there's plenty of capacity with our inflow that only range up to 5000 CFS. All right, I'm going to go ahead and click Apply. And then head over to the Operations tab. And then the first thing to do here is click Operation New. So ask me for a new operation set name and description. I'll just call it Operations Set 1. And then I'm going to be real boring and generic with my top of zones. So for flood control, I'll just say it's 1500. Apply. Observation. It is 1420. Apply. And then for inactive zone, I will say this is 1350. What I'm going to do first is just do one simulation, a base case with no rules. Then we'll come back and add the scripted rules and see what kind of flexibility we have there. So bear with me. We're going to set up an alternative, run a simulation, and then be back on this screen to add those scripted rules. For now, I'm just going to click OK. And then alternative edit. Here's the alternative editor. I'll go alternative new. We're only going to have one alternative. So I'll just say alternative 1. Okay. And then this will be an hourly time step. I'll select the operation set 1. The look back data is asking for a starting reservoir elevation. So for this, I'll say it's 1420. That's the guide curve elevation. And then the look back release will be 2000 CFS because that is the constant release that the inflows start at. All right, the last tab here is for us to assign that inflow at CP1. This is the time series tab. So I'll select that record. Then I'll select the DSS path button. And then I want to navigate to that time series data.dss file that we created. And here is our record. So I'll click set path name. And what that did was it brought in the data. It made that reference. All right, alternative, save. We'll close that. I'm going to save the network and then we'll save the watershed for good measure. And then head over to the simulation module. Okay, so first we need to create a simulation and link it to our alternative so that we can see the network that we were just building. To do that, we'll go simulation new, and I'll just call this simulation 1. So I will start it at May 1st, 2024. I'm going to start it on the 2nd hour so that the look back period can be the 1st hour of the month. And then it will end on the last hour of the month, which is 31 May at 2400 hours. I'll select alternative 1, click OK, and everything looks good to go. I'm going to run this alternative by going right click, compute, and then it ran. And this is going to be pretty boring and predictable, but it's all right. We're just making sure that the system works. Sure enough, we have our reservoir at a constant elevation of 1420. That's our guide curve elevation that we're aiming for. And then in the bottom plot, we see the flows versus time over the month of May. So the inflow here is in black. I just highlighted, and then the outflow, the release, is the exact same thing, as you can imagine. And that's because we have a constant storage and constant elevation. Okay, so looking at this plot, we can start to get some ideas about what we want to do for our scripted reservoir rule. In fact, it may be best to start simple with some other rules that we've already done, like a release rule, like a minimum or maximum rule, just based on a date. In fact, let's do that. Let's go ahead and add a minimum release rule of like 2100 or 2200 CFS. After that, let's go ahead and use the scripted rule to make a maximum rule. I propose we should set it at 3500 CFS. So what I'm going to do actually is just create a trial. I'm not going to touch my alternative scripted because I can't think of anything better. Edit run, and then I'm going to click on reservoir. I'm going to click on the operations tab and then right click, add new rule. And this will be called scripted. And then we'll select the controlled outlet, and this is called script. Okay. So when I click script, it's going to bring up what looks like a bunch of code. So on the far left, we still have our zone rule tree that didn't change. But what we have here is some boilerplate code that ResSim gave us to work with to start with. And then we also have over here, which is called an API tree. So we see time series data and we see APIs. The APIs is like the classes and the methods that allow us to manipulate data. And then the data itself is up here in the time series directory, mostly modeled variables, and then state variables, external time series, and so on. For our first example, we're not going to touch any of this. So let's just go ahead and take a look at the code itself. I'm actually going to ignore the init rule script function. I'm not going to do anything there. But down here where it says run rule script, this is where I'm going to make some edits. Now the default gives me a maximum of 1000 CFS. And what I want to do is say the minimum is 2200 CFS. So I'm going to comment that line out. I'm going to copy that and then come down here and I will just create a variable. This is Python. So we can just say min release equals 2200. Okay. So I'll just copy that variable. I'll paste it in here. What I also needed to do was change this first parameter to minimum. It was stuck on maximum. So that's not what I wanted. Copy the minimum parameter. So this is now a minimum release of 2200. Okay. Apply. Okay. And then compute. All right. Let's right click and plot. And all right, that looks like what I was expecting. So let's look at the bottom plot first. We have our inflow before. We've seen that before. And then now we have our release. And now the minimum release is 2200. So for the first 6 days, we're actually losing a lot of volume and hence elevation in the reservoir. And then once the inflow peaks up, we're able to match the guide curve, and we see that happening until the very end of the simulation when it looked like we run out of water. Okay, let's go ahead and do the other thing, which is creating a maximum of 3500 CFS. And let's look at that result. Reservoirs, scripted. And I'm going to come down here. I'll just copy this. And then I'm going to comment this out because I may want to use it again. But now I'm just going to call this max release 3500, copy and paste. Okay, and I also had to paste in the max parameter. So now we have a max of 4000 CFS. Apply to all of our zones. And then let's right click and compute. See what this looks like. Close and plot. All right. So what we have on the screen is 4000 CFS is our max. And we could have made it 3000 or 3500. Let's go ahead and see what that looks like. And then let me just change this to 3500. Apply. Okay. And then compute. All right. So let's see what that looks like. Go ahead and plot. And sure enough, when we impose a 3500 CFS max, we now have our original inflow, but then the release is topped out at 3500. Okay, going back to our 3500 CFS max, we could do the same thing using some other methods. Instead of just saying the maximum is 3500, we could use some of the model variables to do the same thing. So I'm going to comment this out and then just come down here. The time series, I'm going to go ahead and select the reservoir. Where I'm going to say if the inflow exceeds 3500 CFS, then set the maximum release to 3500 CFS. And let's see what happens there. So I'm going to go reservoir one, and then let me make a little bit more room. The flow in the pool is what I'm looking for. So I'm going to create a variable. It's going to be called inflow time series. And then what I'm going to do is just leave my cursor here and then double click. Okay. So I double clicked and then it just basically brought in this reference to the time series. So I don't have to know all the methods and parameters. The ResSim script editor here basically provides a lot of assistance with regarding to building these scripts. So that's awesome. And what I do need to do is get the actual values. What I have here on line 49 is the time series. So if I want the actual inflow, I need to say inflow equals inflow time series. And then I need to get the actual value from that time series, which is actually going to be the end of the previous step. So to do that, I'll say get previous value, I believe. Hold on. This is a method that you can find down in the APIs, and it's going to be under time series, and then get previous value right here. So yeah, what I could do, let me just delete this, get previous value, that's it. And then the parameter it's asking for here is the runtime step. So what you want to do is just copy this current runtime step parameter, which is right here. So I'm going to copy that to my clipboard, got it, and then paste. All right, so this should give me my inflow. So now what I want to do here is just say if inflow is greater than 3,500, then I'll say the release is 3,500. Okay, and then we need to grab that max release code from above and paste it here. Max rel, I'm calling it this time. All right, let's apply and see what happens. Okay. Then we'll compute. Close. All right, let's plot our results. And it looks similar to what happened before. We have a huge peak, and I think I know what's going on there. Let me zoom in real quick, though, first. This range. Okay, so here's the inflow. Here's the release, and sure enough, it does have a maximum of 3,500 CFS for almost the entire time, except for what looks like just 1 hour or 2 hours after that water surface elevation, or once the inflow is now below 3,500. What we want to do is just make a little modification to also include the water surface elevation in the reservoir and make sure that it's below the guide curve of 1420. So I'm going to go back to the scripted rule. So what I've done here is I've got the inflow data. I'm just going to add a comment and say inflow. And then I'm going to give myself a couple lines here. I'm going to get the water surface elevation, and that's going to be a time series as well. And then I'll deal with this logic down here in just a moment. Water surface elevation time series equals. Now, what would you do? Pull up the model. This is where we have our model variable, reservoir one, our only reservoir. And we have pool elevation. It's the first one here. So I'm going to put my cursor over where I want it to insert, and then click pool elevation. And, there's a disabled insert and script button here. I think that's another way to do it, but it looks disabled. What has been working for me, though, is just double clicking, like we did before. And there, I've got my time series. All right, so let's get the actual value. And this is going to be from the end of the previous time step, just like we did for inflow. So we'll say water surface elevation time series dot, and then get everything else is the same right here. Copy, paste. So we have water surface elevation and inflow. Okay, now I'm going to, here, I'll just call this set max release as my comment. And I'm going to modify this if statement here to say, if inflow is greater than 3,500 or water surface elevation is greater than or equal to the guide curve elevation, which probably has its own time series constant over here in the API, but we'll just type it in for now, 1420. And then we're going to set this information as it is. Okay. So we'll go ahead and click apply and then okay. So I'm going to go ahead and compute that, and we'll see what happens. And I have an error. And hold on a second. I think I had a syntax error. 1 second. I'm going to go back to reservoirs script. And I need to brush up on my Python because I think this is supposed to be an OR, like literally OR. If I do the script, then yes, this was my problem. This might be a good thing to try out as well. If you ever have problems with the script and the syntax of Python, then clicking this compile script button will alert you to some potential errors. And what I need to do is type in or here. Actually, I think it has to be lowercase. Then let me do the compile script. Okay, so that was successful. Let's go ahead and compute. Okay, that looks good. And then let's take a look at the plot. And sure enough, this is now what we want. This indeed mimics what we saw when we set the constant, the 3500 CFS the previous way. All right, so that's cool. Now we can go ahead and modify things. We could go back to the script here. And then I could do something like drop it down to 3000. But then the max release isn't 3000. It can be 3000 plus inflow minus 3000, maybe divided by 2. Apply. Then okay. And then let's compute it. So it can exceed 3000, but it would only go up to 4000 because that would split the difference between the max inflow and 3000 and plot. Okay, so this is a little bit different shape. And we're starting to get a feel for the customization of and the power of using scripts, because something like this would be kind of hard to model using a combination of function release rules and if statements, if blocks, but using scripts, that's maybe a little interesting. Okay, so that's a different way to do it, certainly. One more modification I wanted to just try while we're on the topic. I'm going to go down to scripts, and instead of inflow, we could say it's not divided by 2, but maybe like raised to the like a square root here, or maybe just like say 0.8 would be a little bit less aggressive. I just want to see what happens here. Okay. And then this may actually provide a little bit of a rounded. Something happened. A negative number cannot be raised. Oh, okay. That's right. So I need to change it to an and. Hold on. So what it told me there was that this is sometimes a negative number if the inflow is less than. Okay, so let's just change this to an and. I think I also want to just specify max release is 3000 above the if statement. And then I would also have to move this outside of the if block. All right, I think we're good there. I'll click apply and then okay. And then compute. All right. And plot. All right, interesting. So yeah, we do have what kind of looks like a rounded shape based on that raising the difference to the 0.8 power. But anyway, that's fun. Let's go ahead and try a couple more things while we have the script up. I'm going to go ahead and go back to my script, and we're going to try something completely new. Well, actually, what I'll do there is I'll just change these numbers to 4000. This rule will still be active. And then on top of that, I'm going to say release exactly 2400 CFS on May 24th, and also release exactly 2700 GFS on May 27th. Okay, so obviously we can do this with function release rules, but I want to kind of show you how that would work here in scripting. All right, so what I want to do is get a function for the date, see what that looks like in ResSim, and then we can build our Python around that, and then ultimately a rule sort of like this, but specific instead of max. Okay, so I go over to HEC time, and there's a date function here. So that is the date that I wanted. Get HEC time, I think is it. Let's do get the time at the current step. Yes. Okay. So get HEC time and then date. So I'll do days. Okay, so I'll just say date equals get HEC time. Okay, so what I want to know is like what does it actually display? What's the format of the date so I can match it when I provide my Python code to recognize the exact date or the day of the week or the month or the hour, whatever the time step. But right now we're just doing dates. So what I want to do here is just print out the date. I'll just say print date. And actually, let me go ahead and give it a concatenate, date, concatenate, and then a few more asterisks. Let's go ahead and click apply, and then okay. So we're going to run the compute, but I also want to bring up the tools console log here. And this is how it's sort of rudimentary, but it's the best way, one of the better ways I've been able to figure out how, what variables actually are if I'm running a script and I'm stuck in a loop or something and need to figure something out. So here's the console log. I'm going to just kind of keep that there, return to it. I'm going to run the script. So I'll click compute, hit computed. Now, if I come back over here, you can see the scroll bar gave me a lot more data. And so if I start scrolling down, I can see the dates. And this is, remember, an hourly time step. So I'll see the same date posted 24 times here. But that doesn't matter. What I'm just curious is the format. So I'm going to go ahead and get that format copied onto my clipboard and then go back over to the rules and then scripted. And then first I'm going to just start with a dictionary. So there's the format there. And then I'm going to say rel data would be a dictionary. So I'll say rel data, and then my first record will be 24 space May 2024. That'll equal 2400. Then I will add another record for the 27th. Okay. We don't need that anymore. Thank you. Okay, I don't have to print the date, so I'll just comment that out. Get the date in rel data, specific release equals rel data date, lowercase d. I think that's good. So the last step is to specify that specific release. So it's not a maximum, it's not a minimum, it's an exact value. So to do that, we're going to have to paste in that right there. And then this specific value is the comment is here. So the first parameter will be this right here. That should go right there. Paste. Okay, so we still have the original rule of 4,000 CFS, as well as we're just going to say, hey, on the 24th and the 27th, go ahead and give us, I think this needs to be a string, go ahead and give us 2400 and 2700 respectively. All right, I'm going to click the compile script button. Okay, that was good. That's so far so good. Apply. Okay. And then this will be our last one, compute, if it works. And plot. And all right, looks like we're good here. So on the 27th, we have, in 24th here, I'm going to zoom in. Here is the release, and sure enough, 2400 and 2700. Now we didn't set a minimum, so what it's trying to do is reestablish the guide curve elevation by releasing 0 for a number of hours at the beginning of the next day in both these cases. But what we have here is exactly what we were looking for. All right, so that was a video exercise there on release script rules, how we can write Python or Jython script to have a little bit more flexibility and power over how these reservoirs should be releasing water in ResSim.